Hello everyone, welcome back to Data Programming 1. Today we have lecture 35. It's the second part of our investigation into databases. I hope everyone is doing well and is staying safe. I'm going to begin today with a couple of announcements. First, P9 is due today, Friday, April 17th. P10 was released on Wednesday. It's due Friday, May 1st, and please remember that late days may not be used. Alright, we've received clarification on what we can do with our final project. We expect to release that next Thursday. It'll be due on May 3rd. We chose May 3rd because that's the day our final was scheduled for. The format of this is going to be very similar to the other projects. It's going to look a lot like P2 through P10. But instead it's going to be a comprehensive review of all the topics covered during lecture, readings, labs, and projects. If you're looking to study, the best place to start is by going over your old projects and making sure that you understand everything that went wrong on any of those and just anything you may have forgotten. It'd be good to just touch up and review those things. All right, next up, there's a Google form for grading issues, resubmissions, deadline extensions. Me and I are being overwhelmed with emails, and so we want to make sure we don't let any of this slip through the cracks. Again, if you sent me an email and I haven't replied yet, please send it again. I missed you. Sorry about that. All right, course evaluations came out today. Me and I value this feedback very highly. The evaluation is anonymous, and we don't actually get the results until after the final grades are turned in. So if you have feedback sooner, particularly about today's lecture, I'm going to try something a little different. I would love to hear it. Go ahead and leave a comment in the YouTube section, or you can use our feedback form online from the webpage. Let's see here. Next up, Piazza. So what we're finding is that we're also getting just a ton of private posts with basically a whole bunch of code with a comment like, why doesn't this work? And we're being overwhelmed. We're having trouble keeping up with all of the Piazza posts. So I want to just go over some strategies. If you're finding that we haven't gotten to your Piazza question yet, it's because there are a lot of them, particularly in the last 48 hours. So some strategies. First, look to see if there's another post about the same question. A lot of people, are running into the exact same problem you are. Check the P9 folder if it's about P9. Check the P10 folder if it's about T10. The title, put the question in your title when you ask a question, or look for other people who, the title has Q9 in it if you're looking for something about question 9. And check you can sort by recent date to get the most recent projects if you're not looking in the right folder. So as you go through, as you're about to post something to Piazza, go back and add comments to your code to explain what each piece is supposed to be doing. If you have a loop there that's going to add things to buckets of a dictionary, put a little comment in so that when the TAs read your code, they can say, oh, I see what this loop is supposed to do. And just take a little bit in those comments, explain the strategy that you're using. If you're bucketizing by the year, if you're bucketizing by an actor or a director, put that in the comment. So we can see what you're doing. A lot of these problems can be solved by bucketizing more than one way or trying different things. So by just explaining what you're trying to do, that'll help us spot what's going wrong a little more easily. Number 4, do your variables have meaningful names? I make this joke, and it would actually be really funny if I hadn't seen it once, but someone was trying to compute the area of a rectangle, length times width. And the variable names they chose were TT and TTT. So TT times TTT equals TTTTT. And that was the area of the rectangle. Horrible, horrible names. Never do that to me. Please don't do that to me. But the TAs need to be able to figure out what data that these variables are supposed to contain. So go back, make sure they're named something useful. And then go ahead and add some print statements to print out the contents of the variables and their types so that the TAs can see what it is, particularly if it's not something that, maybe something you defined much earlier and isn't actually in the screenshot of your code. And then finally, number 6, we need a screenshot of the error message or the incorrect output that it's generation. And we'd like to be able to copy and paste the code into our own notebooks to test this. So if we can actually get the text of the code, that would be great. Screenshots are a little more work for us to figure out what's going on. All right, so today we're going to be continuing with SQL. Please remember, just a quick review as we get started, that we're going to be using pandas. So I've got PD here. And the command to access SQLite through pandas is read SQL. And then that requires 2 things, a question or a query, a SQL query, and then the connection object. So we've got 4 things here that are essential for narrowing down a data table to extract a piece or a subset of that information. Just want a quick review what they are, and then we'll go do some examples where we use these. First up, the important one is from. That's what's going to happen first, even though it's ordered second when we have to put it in. That was a design decision made a long time ago by people, and I'm not sure it's the best to put it in second position. But anyway, so this is from is going to tell us which table we are grabbing data from in a database that has more than one table. All right, next we're going to be selecting columns. So the select is going to narrow the table down to a subset of the columns. Third, where is going to take a Boolean condition. It's going to ask a question, and for each of the rows, it'll be either true or false. And for all of the rows where that question is true, we're going to retain those. And we're going to eliminate all of the rows for which that question is false. And finally, the limit option is going to take another parameter, a number, and that's just going to say only give me, limit 3 is going to give me 3 rows. Limit 10 is going to give me 10 rows. So I'm not overwhelmed with data if I just want to take a look at things. Okay, so these are the narrowing down. Yeah, select those columns, from, choose the table, where and limit, so narrow down the rows. All right, we also have a 5th option, order by, and this is going to be the one that takes care of sorting for us. And there are 2 versions of that. We can sort by ascending order, where numbers go smallest to largest, or descending, where they go from largest to smallest. And today we're going to be adding 2 new functions, group by and having. Group by is essentially what we saw with bucketize, where we're going to take our data table and break it into smaller data tables where all of the rows have something in common. We'll be grouping the rows, and then we can do some sort of aggregate statistics on them. We can sum part of the data, or for each, think about it like buckets. So if I have a group of buckets, I can take each bucket and I can compute the sum of the data in there, in each of the buckets. And then finally, having is the new way we're going to be using that to filter out particular groups. So we can select, narrow down by group using the having. Okay guys, so here we are looking at the web page. I want to do something a little bit different in class today. Watching a video of me lecturing is probably the absolute worst way to try and learn how to work with SQL or learn Python or any of that stuff. The best way is, of course, to actually do it yourself. And so I want to do as much as possible to bring that aspect in. So I'm going to do something a little different today, and I want you guys to tell me in the comments whether this was good, whether this was useful, better than what I have been doing. I'd love to know. So here's what's going on. We're at Databases 2 right here today. There's a code file, a code directory here. It's just a GitHub repository where there's a bunch of files. Let me real quick switch over. Yep. So I've already downloaded these. I've got them on my computer, and I've opened them up in Jupyter Notebook so we can see what's here. There's a lecture right here. This is the template for today's lecture. You can see I practiced this just to make sure that I know what I'm doing, and I'm still going to make a ton of mistakes. But hopefully those will be informative too. This is the file I'm going to use today. I'm going to fill this out as we go through, and it'll still be available in the GitHub directory, so you can download the exact code that I'm done with after I'm done talking. And it's just a series of questions about the movies database right there. It's got some images I've imported, so those files are here also. And finally, I've got a second version here, the bus notebook. This is going to be asking questions about the bus data set, right there, bus database. And I'm providing the answers for those also. So you guys can, what I recommend is follow along, pause the video a lot as I get to a question. You'll see in a moment what it looks like. And then after you're done, go back and try and do this bus notebook on your own. Okay, here's the one for today. So we're on Database 2. Got a little header up at the top. Let me just walk through this a little bit and give you an overview of what's going on. So I've got my import functions. I've got my change the way the display looks. You can ignore that. We'll be connecting to a SQLite database. We'll be reading it in and just looking at the SQLite master. And then I've just got a bunch of questions here. So for example, some review questions. What movie in the database has the highest rating? What director has the shortest movie? The kind of things we did with the Hurricane project and the movie projects. And then we'll be taking a look at these new functions, the sum, average, count, min-max, things that will take a column of data and give us a summary back, some aggregate data. Things like counting the movies, counting the directors, adding up the total revenue. And then we'll take a look at grouping. So we'll come up with, this is the bucketized version of things, per year. So we'll bucket by year. What is the total revenue? How many movies were by each director? So we'll bucket by the directors and do some of those. All right, but that's kind of the idea. So let me start at the top here. I'm going to run this first cell to import SQLite 3 and pandas. All right, this cell right here does two things. It's going to change all of my styling to red. In fact, you can see that down here at the bottom where I've got which movie has the highest rating. Just a little flair. I got this from Tyler. I think he was mostly just showing off, but I really like it, so I'm going to keep that. And the second part is use the extra width, use the full screen. Just for the video, it looks better. You guys can see more of what's going on. Okay, and then this next piece here, we will connect to the movies.db, and that's going to return a SQLite connection object at that memory address. All right, very good so far. After that, the first thing we should always do when looking at a new database is just memorize this, select everything from SQLite master. This is just going to give us a summary of all of the tables. It requires that connection object, and we can see that this database has exactly one table. Here's the table. Its name is movies. Table name is movies, and here's the function that was used to create it. So let's take a look at what's in that function. So I'm going to use pandas to call SQLite read. I'm going to select star. That's select all of the columns for movies. That's going to return pandas data frame, and we'll use head 15 to just take a look at the first 15 rows of that. And we'll see what we get here. I'm going to make this a little bigger. Sorry about that. I should have done that right away. I realize that some of you guys are trying to watch this on mobile devices, and if you can't read it, that's no good. All right, so here's the data frame. I've got a bunch of movies. Titles, Guardians of the Galaxy is the first one. I've got directors, the year they were produced in, the runtime, rating, and how much money they made, their revenue. So it's a lot like the movie database we use for the project. This database is much simpler though. None of the movies have more than one director. They all have exactly one director. And we didn't worry about keeping track of multiple actors or any of that kind of stuff. So it's simpler than the one we were looking at before. All right, now I'm going to do one thing to make our lives a whole lot simpler today. So today is all about using SQL, and to run a SQL query, this is the command I need. I need to use pandas to read some SQL, and then I'll give it that query string, and I need a connection. And then I'm just going to return some results. Since every single, to be honest, there's almost 1,000 movies in this database, and I don't want to have to deal with a table that's got 1,000 things in it. So I'm just going to straight up take the data frame and call head on it and cap it using this query function. So the query is going to take my SQL command and how many I want to return. So let me just demo that. So I'm going to just use query function. Whoops, I just forgot to run the cell. So run that cell. Now query is defined. I can run this. And now it's just going to do the same thing, except using the function. It's going to return all the columns. It's calling this. This is my string here that I'm. Oops. The query string for the SQL command is the one I'm using here. And I'm using the default value, so it's only giving me the first 10 rows of the database. All right, that's all that's doing. All right, so to quick quick review now. I'm just going to go through, and as sort of an exercise, this would be a great place. I'm going to do this first one right here. Pause the video, and then see if you can go do it yourself, and then come back and watch the video. And if you need to see me do the first one, there's a bunch of review questions here. You guys should use this as an interactive learning tool. Go do this yourself. You'll learn more by doing. All right, so first up, let's take a look at this. This is just a real cell right here in Jupyter Notebook under cell. I have different cell types. I can either use code. That's what we've been using so far. But it also lets me use Markdown. So let me just, this is Markdown. Let me switch it back to code so we can see what that looks like. So this is just, it's a lot like HTML. It's a way to format text so that it looks good. These pound signs right here tell me what size I want the text to be. And the stars here are the emphasis, so that's what's changing the color. So in fact, if I just want to change some of these, if I want to use fewer stars, we'll run that. We'll turn this back into Markdown. We can see it gets much bigger and is sort of the header style. Let me put that back. I just thought that was kind of interesting in case you guys want to see that. Or if you want to ever use this to decorate your notebooks, if you want to turn in something that looks gorgeous, feel free to do that. All right, so cell type, we'll put that back in Markdown. All right. All right, so here we go. Next up, I've got a cell selected. I'm in edit mode. No, so I forget what that's called. But anyway, if we push B in this mode, that adds a new cell below that. Pushing A will give me a new cell above the one I have selected. So I had the which movie is the highest rating selected. I pushed B. I've got a new cell. When I click on it, it turns green. That's the one that's called edit mode. I got to figure out what that other one's called. It'll come to me. Okay, so now what I'm going to do is I'm just going to write a SQL query that answers the question, which movie has the highest rating? So to do that, I'm going to use my query function. Need parentheses. I'm going to give it a string. I'm using triple quotes so I can space this out and make it look good. And every SQL query requires at least two things, the select and from. So it looks like I'm selecting which movie has the highest rating. So I want to select the movie column. And the movies are under title. So I'm going to select title from, I've only got one table. It's called movies. So that should give me just the titles. Now I also want I want the highest rated movie. So I'm going to order by rating. And let's see what that looks like. Okay, great. So now I've got movies. I don't recognize any of those. I think something highly rated would be something I would recognize. Let me take a look here. Let's actually also include the rating. Oh, I screwed up. All right, hold on, guys. Look at this. So I've actually ordered them. They're ordered 1.9, 2.7. It's increasing. But the highest rated movie would actually mean that I need to order them descending. All right, there we go. Okay. Yeah, there we go. Dark Knight. I saw that. Inception. Those were good. All right, so that would make sense now. So, yeah. Let's take a look at the next one. So, pause the movie, pause the video, go try this one on your own. See if you can figure out which director made the shortest movie. And now I'm going to do it. So I'm going to push B to get a new cell, click it, it turns green. We're in edit mode. I'm going to ask a SQL query using my function. So, which director made the shortest movie? I'm going to be selecting the director. There's only one database table. That's movies. And I want to know who made the shortest movie. So I'm going to order by, I believe it was called Runtime. Yes, Runtime. Let's see here. Order by Runtime. And then, let me put this up here too, just to make sure that I'm not screwing up. Okay, here we go. So now I've got the director. Yep. Made the shortest movie. It looks like 66 minutes with Cloud Barris. And now I only need one of those. Which director? So I'm going to limit to one. Typo there. There we go. You know what? This one only asks for one too. Which movie had the highest rating? Yeah. Limit one. Hopefully you guys caught that at home. Dark Knight. Perfect. All right. More of the same here. Let's add a new cell. Which director made the highest revenue movie? So I'm going to be writing a SQL query. I'm going to be selecting, obviously, the director from movies. Put those back. All right, now highest revenue. So I want order by, and I believe it was called revenue. Let me just check that. Yep. That didn't give me an error. Let's actually break those out too. So now I've got two columns there. That's definitely not highest. Order by descending. All right, there we go. So it looks like J.J. Abrams, he's famous. I bet he made some really good, expensive movies. Yep, revenue, that's in millions, so 936 million. I wonder what the title of that is. That makes sense. The Force Awakens. All right. So highest, I also want to do one more thing. Just limit to one to just get me that top movie. All right. Next up. Which movie had the highest revenues in 2016? So this is very similar to this one. In fact, I'm just going to copy and paste this here. And now instead of selecting the director, I actually want the title of that movie. And I also want to restrict my search to just 2016. So right after from here, I need to add where year equals 2016. Okay, so that's going to remove all the rows that are not from 2016. In fact, let me put the year up here just to make sure. I'm going to take out the limit just to make sure that everything I get is from 2016. Looking good. I'm going to put that back because I only want one. And yep, highest revenue. Ordering by revenue, it's descending. That looks good to me. All right. Oh, very similar question. Which 3 movies? In fact, I could just copy this. I can add a new cell, paste this. Limit 3. Done. All right. Which 3 movies had the highest? Oh, this is a good question. I love this stuff. This is just fun. I hope you guys like this format. Okay, which 3 movies had the highest rating to revenue ratios? And we're going to use the new function here as to help solve this. All right. So there isn't a rating to revenue ratio in our table. In fact, if we just remember what the columns are, so we'll select all the columns from movies. Have a look at that. There isn't a rating to revenue ratio column. We need one more. So instead what we're going to do is create our own. Let's see, a couple things here. First, I actually want which 3 movies. So I want the title. And then what I want to sort by to get the highest is actually rating divided by revenue. Okay? So that will create a brand new column that does that math. It's going to take the ratings, divide by the revenue. And then when I put in as, I can name that something else. I'm going to call that ratio. So it'll add a new column there called ratio. And then I can sort by that. So let's see here. Order by ratio. But it would be good, instead of dividing by 0, to sort those descending. There we go. And now I only really care about the top 3, so we'll limit to 3 movies. All right, yeah. So just to quick summarize, I'm able to do math on these columns to create a new composite column, rating divided by revenue in this case. I can rename that column using as. In this case, I'm naming it ratio. And I can use that new column to do things like order by or select with where. So, and in this case, so I don't know, rating to revenue. I suppose if I were Netflix or something looking at what movies are really good out there that didn't make a lot of money that I might be able to get cheap, I might take a look at those. I haven't actually seen any of them, so I don't know if they're any good. All right, so next up, take a look at aggregate query. So this is where I'm going to take a column of data and try and summarize it somehow. For example, counting the movies or finding the best min or max of something. So let's take a look at this. So if I want to just see all of the movies, query, I'm going to select title from movies. That should give me everything, all of the titles. Now, what I really want is just how many are there. In fact, if I scroll, nope, doesn't show me. What I really need to do is count how many titles there are. So I can actually just use the count function. It's built into SQL and put around a particular title. And that's going to tell me how many titles are present. So this is going to tell me there are 998. I knew it was almost 1,000 titles in the database. In fact, if I just want to count rows, I can use the star there to count all of the rows. So pretty simple, not that much to it. All right, this next one's one extra. Hold on, keeps one more little bit, a level of challenge. Okay, how many directors are there? If I try the same thing, it makes sense, right? I should be able to select directors from movies. Take a look. I spelled some director. I get a list of all the directors. Okay. Now, if I want to count those, just like that, I still get 998. The problem here is that some of those directors produced 4 or 6 movies, and they're being counted many times. So to count and remove all those duplicates, what I need to do is count distinct. Hold on. Yes. I can spell. I so can spell. Okay, count distinct directors. So that's going to not count any duplicates. And 643 is much closer to what's really going on. Most of the directors in the list, we've only got 1,000 movies. Most of them are only produced 1 movie. All right, so next up, the total revenue of all the movies. So in this case, what I want to do is take a look at revenue from movies. Let's take a look at this. So here's the first 9 movies in the database, and the function I want to use here is I want to sum the revenue. That's going to take this entire column, add them all together. Sun, yeah, and then I'm going to get a tan. Let's try that again. Sum the revenue, and then return it as a data frame with exactly 1 row. And in this case, these are in millions, so we've got $72 billion. That's about right for 1,000 movies that are some of the best movies out there. Okay, so sum is the function. We just put it around the column we want to add up and returns this aggregate data, the total value. All right, next up, let's take a look at doing an average. So I know what an average is. That's where I add up all the values and I divide by how many there are. That's one way to do it. SQL also comes with the built-in function. I'm gonna do both of these. So first up, I'm gonna use my query function. We're gonna select, in this case, let's see, average rating. So let's just take a look at rating to start with. There they all are, lots of ratings. Okay, and now I'm gonna do the sum of the ratings. That's a big number. Okay, now I need to divide by how many there are. Now there's 998 movies, but I don't want to hard code that. I'm going to instead divide by the count of all the rows. Okay, so that's going to tell me that the average is 6.72 for average rating of movies. It sounds pretty reasonable to me. All right, so I'm going to click over here on in. That makes it blue for whatever mode this is called. Add another cell, and we'll do this the other way now. So select. Now in this case, rating from movies. I'm going to use the other function. Average is AVG in SQL. I'm going to mistype that several times. I'm going to write AVE and then not spot it. You guys can laugh at me at home, but I got it right the first try. All right. In this case, it's going to take the rating column, compute the average of them. It's just built in. Average is so frequently used when you're looking at statistics and data that they just have this abbreviated to 3 letters. And we got the same number, 6.723. So looking like it's working. Okay, so let's do the next one. What is the average revenue and average runtime of all of the movies? All right. So let's get a new cell here. There's no reason we can't do 2 averages in one table. So let's take a look at that. Query. I'm going to select, let's see, revenue and runtime. And from movies. Let's get that. All right, now what I really want is not just the table with everything. I want the average. I'm going to spell it AVG again, get that correct. And AVG, average runtime. All right, this is going to create a new data frame for us in pandas with exactly 2 entries, one the average revenue and the average runtime. No reason we can't just continue to add things. Okay, so next up, let's make this a little more complicated. The average runtime for a James Gunn movie. Okay, so first thing I want to do is basically remove all the rows where James Gunn was not the director. So let's start with that. Query. Let's get print out the title and the director, and then we'll take a required from movies line, and we'll do a where director equals James Gunn. And I'm pretty sure I need to put James Gunn in quotes. All right, let's take a look at that. How many movies has he done? Guardians of the Galaxy, Slither, Super. So we got 3 here. And now we're going to be looking for the average runtime for these movies. So I've just removed all of the movies where he was not involved. And let's see here. I actually want to select the runtime and take the average of that. Very good. 104 minutes. All right. Average revenue for a Ridley Scott movie. Okay, this question is very similar. Add a new cell. So let's take a look again. We'll select, we need a director. And we're looking at revenue. And because I'm curious, we'll see which movies Ridley Scott has done that are in the database. From, movies. And now what I want to do is remove all the movies that were not done by Ridley Scott. Director equals Ridley Scott. Okay. There we go. Looks like Ridley has done 8 movies that made it into the database. Very good. All right. And they've got revenues somewhere between, looks like 7 and 228 million. So next up, what I really want to do is take the average of the revenue of these movies and find out that the average is 89. That would be million. Okay, cool. How many movies were there in 2016? So here I'm going to select, let's see, I would really like, let's actually just print out all the movies that were from 2019. 2016. From movies where year equals 2016. All right. So a bunch of movies. Let's print out the year too, just to make sure they're all, yep, looks like 2016. Looks like we actually have 10 of them. So let's just make sure if I were to count those rows. Oh, wait, I'm an idiot. I'm using my function that limits it to 10 rows. Certainly there are more than that in the movie set with 2,000, with almost 1,000 movies. Okay, in fact, 296. Let me put this back for a second. We go title and year, and then remember my query function had that head function that limits the data frame to 10 rows. In fact, if I were to put in up to 1,000 rows, we're going to limit it. In fact, we do get 296. Okay. That was just me being dumb for a moment. So instead, we want count star. There we go. All right. Excellent. Let's see. What percentage of the total revenue came from the highest revenue movie? Interesting. Okay. So I'm going to add a new cell. And let's see, what's the best way to do this? I'm going to select from movies. What I really want here is the, let's see, percentage of the total revenue. Let's get the total revenue first. So that's going to be the sum of revenue. Okay. There we go. 72 billion. We've done that one before. And now the highest revenue movie is going to be the max. So there we go. Max revenue. That was from Star Wars Episode 7, The Force Awakens. Interesting. Okay, so what I really want to do now is the percent is going to be max divided by total. So sum of revenue. And to make this percent time, whoops, just 100. There we go. So it looks like Force Awakens was 1.29% of the revenue of all almost 1,000 movies. All right, interesting. Okay, what percent of the total revenue came from the highest revenue movie in 2016? So this is very similar, except now we want to do one more step, and that's only look at the data from 2016. So to do that, we need to remove a bunch of rows. or narrow down to a bunch of rows. And we're going to do that with the where function. So I'm just going to copy and paste the one I just used to get the percentage of the total revenue from the previous question. And instead, I need to add one more little detail, where year equals 2016. Okay, so I wonder what movie that is. Hold on one sec, I'm curious. So what I want to find is the max revenue from 2016 and grab the title. Oh, Rogue One. I'm a huge Star Wars fan. That was a good movie. All right, so that's it for the quick review. Next up, I want to talk about bucketizing, and that's going to be the group by style queries. So maybe the best way to look at this is to just real quick start with an example, and then we'll talk about how it works. So what is the total revenue per each year? If we were doing this in Python, we would use our bucketize function. We'd create a dictionary where the key was a year, and then we would put the revenue in the value and just go through all of the data and add to the value for each year in our buckets. So SQL provides a way to do this for us. And it looks like this. So I'm using my query to get a SQL function. I'm going to select from movies, and what I really want is the year. I'm selecting per year, and I'm going to group by year. So this is going to go through and take each of the year and make their own table. It's going to sort all of the data into essentially their own table. I'm going to be selecting year, and then I'm going to be printing out the total revenue. So that's going to be sum of revenue. Let's take a look at that. So in this case, here's all of the years, 2006, 2007, all the way up to 2015. Oh, that's right. Oh, I'm only printing out 10 of them. Let's take a look at all of them. So we'll limit to something bigger. There we go. All the way up to 2016. And then total revenue, this is going to be in millions again. So $3 billion, $11 billion. All right, excellent. If we were to do one more thing, if I have a group by and I were to just throw in something else, it's just going to choose at random one of the titles from this bucket or from this, sub data table that we've just created. Oh, The Prestige. That was an excellent movie too. All right. Oh, I'm getting off on tangents. All right, I'm going to take this out. Don't ever do this. Once you've bucketized, only include aggregate data. Something else, anytime I use the word group by, that should be one of the things I'm selecting. Whatever's here goes here. Everything else gets some sort of aggregate function, sum, max, whatever, something where it's going to be analyzing the entire bucket of data. Because this is basically the key for the bucket, and this is the value, and we only get one thing here. Okay, so let's take a look at some more examples of this, just to learn by doing. Okay, pause the video, go see if you guys can figure out this one, and then come right back, and I will do it. All right, how many movies were by each director? So in this case, I'm going to bucketize by the director. So query, I'm going to select. Looks like we're by each director. Every time on each or per means I want to group by something. So I want to group by director. Then up here, I always need a from to tell it which table it's from. So I've selected director, and I want to know how many movies there are. So I'm going to count how many movies they've made. Okay, and this is going to give me the first 10. It might be interesting to see who made the most. So we can also do this order by. Okay, let's do it this way. So I introduced the as function a moment ago. So I'm going to say count as, we'll just call it count. And I'm curious who made the most. So descending. Ridley Scott made 8. Okay. I don't know. Maybe this count is confusing because I'm reusing the word. Let's call it movie count. I can order by that composite data. All right, let's do the next one. What is the average rating for each director? Check this out. I've got the words for each right there. That is a clear sign that I want to go ahead and use a group by. So query function select from movies, and I want to group by. Hold on, I get here. Grouping by director. Okay, so if I'm grouping by director, then I want to print out data for each director. So we'll put director here also. And what I really like to print out is this group by is going to take my data, divide it up into lots of tables, and each of those tables I'm going to take a look at one at a time and compute the average rating. AVG, not AVE, AVG. Average rating. All right, so for each of the directors here, I've got an average rating. Yeah, looking good. What is the average runtime for each director? Oh, this is so similar. I'm just going to put it up right here. Average runtime. We'll get those in there too. All right, so I've just answered this question, average runtime, right up here in this second component from the select. Okay, how many unique directors created a movie in each year? All right. So it looks like in this case, I'm going to be bucketizing by year because I've got an each year. Query select from group by year. Okay, now I want to know per year how many unique directors there are. So I'm going to count the directors. And its column name is just director from movies. Alright, I did something wrong. Alright, got a mistake. Oh, here it is, right here. I forgot the comma. Select year, and then the next column over should be the count. So this is going to say that I've got, in this case, I'm not actually counting directors yet. I'm just counting rows. And it's just director, not directors. Okay. Ooh, interesting. Let's call that as director count. There we go. Now I've got the column labeled better. So that says in 2006 there were 44 directors. Now this is not actually unique directors yet because if a director produced more than one movie in 2006, he's going to be in there twice. To get unique directors, I need to add the keyword distinct. All right. That looks like all of the directors who produced movies in 2006 were only producing one movie. All right. Anyway, so there we go. We've used group by year and counted the directors. Okay, so those were some pretty simple examples just to introduce the topic of grouping. So when we want to start doing things that are a little more complicated, remember that SQL requires all of these features, keywords, to be in a particular order. And group by needs to slide in right between the where and order by. So we'll be selecting columns from a table. We're going to limit the rows. And then after we've selected some rows, we can then group by those rows. And then finally, once we have the groups, this order by will then be arranging the groups in order, and we can limit to a certain number of groups. All right, so let's take a look at a couple more complicated examples that bring in some of these ideas. So what is the... Okay, let's do this one. Which directors have had the largest number of movies earning over $100 million? Okay, so looks like we'll be grouping by directors. So let's start with that. Select from by directors. Okay, and now we want to know how many movies they've had. So we'll be selecting directors, and in all of these categories we're going to be wanting to count how many movies they have. That's just count the titles. All right, but with restriction that they need to have earned more than $100 million. So before I ever group them, I want to go through my data and use the where function and give it a Boolean value that says where revenue is greater than 100, and these are already in millions. And now let's see, I have a typo somewhere. director. Okay, there we go. So this is going to go through, and this is going to tell us which directors have basically counted them. Movies earning more than $100 million. Let's change that up a little bit so that that's actually, all I did was relabel the column. All right, and then what I want to do is order them so I can get the largest number of movies. So let's do that. After we've grouped them, then we're going to go ahead and sort those groups. So order by count. And I want to know the largest movie, so descending. So this is going to tell me that David has 6 movies, JJ's got 5, Zach has 4 movies that have earned over $100 million. All right, very good. Which 3 of the directors have the greatest average rating? Okay, which 3 of the directors? So this means I'm going to be grouping by director, and then I'm going to compute an average rating for all the movies by each director. Select from order by, whoops, this should be group by. So this will make, so group by is going to take all of the movies, sort them into groups of directors, so we can print out the director. And what I want is the average rating. So average rating, and I'm going to relabel that new column as average rating from movies. Let's run this. So this is going to take all of the directors. There's their average rating. I want to know which 3 have the greatest. So next up, we're going to be order by. And let's see, we'll order by the new column, average rating. We'll make them descending so that we can see them. So this will be the first 3 right here. So to grab just the first 3, we're going to limit to 3. All right, so Nitesh Tiwari, Christopher Nolan, and yeah, let's see. Which 3 directors have the greatest average rating? Which 3 directors have the greatest average rating? Goodbye. Okay, why is that question maybe not the best one to ask? So this is a higher level question here. Just what kinds of questions do we want to ask about our data? And perhaps, I guess, let's do one more thing here. So I'm printing out the average rating. Let's print out the movie, how many movies there are in that each director produced. So in this case, I want to count all of those movies, and we'll add them to the table also. So what we can see here is that Nitesh only produced 1 movie, one really good movie, got a very high rating, but Christopher Nolan has produced 5 movies with an average of 8.68. So I think there's perhaps a strong argument that maybe Nitesh just got really lucky, and Christopher Nolan is a much better director. I actually looked him up. Nitesh actually has produced many movies, is very highly rated, and just only happens to have 1 movie in this data set. There's only 1,000. But anyway, so those are some interesting questions that we're going to need to think about as we consider our data. Okay, so just a little bit here about the order in which all of these steps are performed internally by SQL. So the very first thing that happens, and I'm going to make this all fit on the screen. Hold on one sec. There we go. So this is this image right here is about what order these things happen in. So SQL requires us to put them in a particular order when we ask the query. But then what really happens on the inside, the first thing is it actually selects which table with the from command. It's the second line in a query, but it's the first thing that happens. What this is going to do is select which table. The next step is actually where. So it goes through all of the rows in the table and eliminates some of them. So in this case, I've got a little X here and here, and it narrows down the number of rows. Following that, it goes ahead and does the grouping. So group by happens after where, and now I've got them sorted into all the little different color bins. And then any of the aggregating functions, sum, average, maximum, occur, and take each of these groups and reduce them down into one new row in the result table. After that, and we'll be talking about this in the very next section here, halving is a way that we can filter out groups. Just the same way that where filters out rows, having is going to filter out groups. So we've removed this light blue group here, and this is what's left. After that, order by will take these remaining groups and sort them by whatever criteria we wish. And in this case, we've got the blue on the top, gray, and then yellow. And then finally, after that, limit is the last thing that happens. And that's going to say, in this case, limit 2 is going to remove that bottom one and only return the top 2 results, just to show us the subset of the data. All right, so that's the order that things are really happening on the inside of SQL. There's one thing I left out here. That's the very first thing we put in, which columns are used. And that actually happens the very last thing. It could happen before or after limit. I'm not entirely sure. But if you think about it, perhaps we want to order by one of the columns and then not actually display it in the results table. So it's important that we don't actually select columns until after we have ordered by them. Doesn't matter whether we chop off the columns before or after limit. But select is one of the very last things. It's the very first thing we need to put in for a SQL query, the last thing to happen. Okay, now I want to do a little bit more where we select particular groups. Group by and having go together. In fact, having comes right behind group by in order. First thing, we're going to group them, and then we're going to give some criteria to decide which groups to retain. All right, so I've got 2 more questions here that demo this. And let me make this big enough that we can see everything again. All right, for the folks at home on mobile devices, I hope you can read that. All right, which directors have had more than 5 movies since 2014? Which directors have had more than 5 movies that have been since 2014? Grammar. I'll get that fixed later. Okay, so I'll make this cell active. We're going to write a SQL query that asks a question about directors. So we'll be bucketizing by directors. So select from group by director. And what I want to do now is, let's see. All right, so I need to get rid of since 2014. So we're going to need a where year is greater than 2014. I'm going to be selecting director. So anytime I'm grouping by something, I want to select that for one of the rows I'm going to be in my output. And then I need more than 5 movies. So let's just do, before we restrict ourselves, let's just print out how many movies they have. So we'll do count, and then we'll just do all the titles. We'll count the titles, see what this gives us. All right, I have a typo somewhere. Count title from, I forgot the table. Movies. Yes, there we go. Okay, so it's going to go through. This is going to say that Adam Leon has 1 movie that was created since 2014. All right, what I really want is more than 5 movies. So I have count here. I'm just going to relabel that column as count. And then I've got group by director. After group by, I can use having to now take my aggregate statistic, this count greater than 5. And the answer is 0. No directors have had that. All right, so I suppose if you think about it, the data set doesn't actually go very long. Let's change the question a little bit. We'll just, cell type code. Since, how about 2010? Has anybody done it since 2010? No. All right, let's say since 2010 is actually greater than or equal to 2000. And nobody. All right, who's produced more than 3 movies? There we go. Okay, perfect. All right, who more than 3 movies since 2010? All right, yeah, that's a better question. So I'll put that back. All right, yeah, poorly worded question. Sorry about that, guys. So should have gotten that fixed sooner. Okay, so here's what I've done. I needed to know which director have had more than 3 movies since 2010. So I'm grouping by director. I'm creating a new column where I'm counting how many titles are in the list. And then I'm going to be having, and this is going to select groups. it's going to eliminate all groups that do not have a movie count greater than 3. And then the rest of this, I need to also require that they have been since 2010. So I decided that's greater than or equal to. So it's going to remove all the movies that were from years prior to that. All right, looking good. Okay, I strongly suspect this is going to have the same problem. More than 5 movies with runtimes under 100 minutes. So grab a new cell. Query. Let's find out. My guess is the answer is 0. We'll write a better question in a second. So first, directors with more than 5 movies. So let's just group by directors. From movies. And we also need more than 5 movies with runtimes under 100 minutes. So looks like where. I'm going to need a where and a having. So for the where, that's going to be runtimes under 100 minutes. So runtime less than 100. And let's just take a look and see if directors, man, I cannot get that right, can I? I did it twice. Director. Okay, now there's another. Oh, got the comma there. There we go. Okay, so here's the list of directors where the runtime is less than 100. So anybody in this list has produced at least 1 movie. So next up, let's actually grab the count of the number of movies with runtimes under 100 minutes per director. Okay, so that's going to be count. We'll count how many titles they have. And it looks like a lot of guys have 1 movie. So then, the last thing, having count. Oh, I need to relabel this new column as count. Having count greater than 5. And again, nobody. Okay, let's revise that question. Count greater than 3. There we go, just 1. Real quick, we'll put this back into code. We'll make that 3. Put it back to Markdown and run it. There we go. Okay, so it looks like we have 1 director with more than 3 movies with runtimes under 100 minutes. When I did this, I broke it down into 3 steps. I grouped by the directors. Then I needed to eliminate all the movies that were longer than 100 minutes. I did that with the where. And then finally, the having, it's going to count all the movies and remove all of the directors, all of those buckets or all of those groups that didn't have enough movies in them. Okay, so that's it for today. There's a a notebook that has a number of, I think there's only 7 questions in there. Something, it's not very many, that asks questions about the bus database. I strongly encourage you guys to just stop the video, go and see if you can do all of those. I've posted the answers. They're in the directory with all of the code. And let me know what you think about this style, where I'm doing a problem. You have the opportunity to pause the video, try it yourself. I want to make this as much as possible a learn by doing experience. So let me know what you think. And have a great day.